Here's my 2009 Formula SAE car that I want to get running again and start doing autocross with it. It's 13-inch wheels. I had back in the day Goodyear tires. I think they don't make 13s anymore, so new option Hoosier or maybe another one out there. It's a steel space frame. The body is just flat carbon fiber panels. Some of them are riveted on, other ones have quick release. This is the only part that was molded underneath. It used to be the ECU. This is styrofoam with fiberglass outer skin. Had a bunch of Bondo, so it's way heavier than it needed to be. But that's the impact attenuator, which is required by rules to have. So I said 13-inch wheels. These were Kaisers, and then Willwood brakes in the rear. Same tire size, same wheel. Rear engine, J.E.F.E in this area. Of course, cantilever or rocker arm, whatever you want to call it, suspension. These are King Creek double barrel shocks, which were tuned by Öhlins. Now these are just sold as Öhlins TTX25, I think they are. But these are, I think, 2008 is when we bought those. I think that might have been the first year they started making those. Yeah, radiator. Originally had a Suzuki LTR 450. The Garrett GT12 turbo on it. Used to sit, muffler sat on that pad, it went something like that. This was the first year Formula SAE had to run the cockpit templates due to, like the year prior, their 2008 car was, not a lot of people could fit in it because it'd break your shins just from not a lot of space down in the footwell. But this year he had to run cockpit templates, so couldn't be any smaller than a certain size for safety reasons in case of impacts and just overall fitting ergonomically, different size people. Have the firewall out right now. See more of the space frame. Got these old seatbelts in the way. And we just had this, I don't know what that was. Sound like a tool. Sweet. Yeah, some aluminum on top of a masonite. Have to redo that, make it out of something better. I'll get the panels off and look on the rest of the inside. Got some panels off, the removable ones at least. You can see just a flat sheet of carbon fiber with some sweet Cadillac paint. Now it kind of turns green to pinkish red. But overall it's white, I guess you call it. Got the removable, the one piece that was actually molded. Again, carbon fiber, I think they're vacuum bagged, I think. Or infusion, vacuum infusion. And this is where the ECU used to go. We used a DTA. So we just have all the old wire in here that probably won't be used anymore. And this, if I remember, this controls. Oh, it's off. I don't know where it is. Somewhere in that pile of parts is a paddle shift, electric paddle shift, made for shifter carts. Tried it on this, didn't really work that well, but maybe you can fiddle with it. Overall, this car was pretty heavy for being a single cylinder car. It was 450 pounds, which is heavy for one of these, especially single cylinder. Like the last car before I graduated, we got down to like 350. So it was a 10-inch tire car, but still, this thing shouldn't be 100 pounds more than that one. Looking more at the front suspension, it is a push rod. Got pedals, gas, brake, and we use the clutch one. It's pretty tight in there. Wish we just made the clutch into a hand clutch using like a motorcycle clutch handle, which I'll try to fit somewhere in there if I can. But like this big old clutch cable bracket looks like it's 100 thousandths thick, which it's giant, it's heavy. Like there's no reason that needs to be that big. So a couple modifications I can do as I restore this car to make it more light. Got a wood, I think it's wood something steering rack. And that was actually pretty nice. One compliment we did get during design review was had a nice steering, and still pretty nice. Yeah, adjustable, you know, all the usual tie rod and pull rod adjustments. Here's the diff. It was a inboard brake sprocket onto the diff, this giant spacer to the brake. I think this diff was off a Polaris or a Honda, I forget, but it's like a 4x4 utility style. It's a Cam & Paul limited slip, but Cam & Paul is really not the best for autocross, but there is a version similar or maybe exact kind of dimensions that is a clutch style, which I'll see if I can get one depending on how much they are and replace that with or replace this with that. But just to get this car running, I'll still use this. And it mounted probably hard to see this hole here. One of the holes there, and then yeah, there and over there, which have these diff brackets. Just one I need to remake somehow. I don't have a mill or anything, but the way this is, yeah, not the best. I think the other mount started a crack, or let me see. Yeah, being how long this was. This is where the brake caliper would mount. Again, another Willwood caliper. But I'd rather these were counterbore, but they're not. And then one of them, maybe it was this side. Anyway, I remember one of them was bent just because of that weird 90 cutout instead of a counterbore. Suppose I could get some sealed bearings instead of some open dudes. Got the floorboard off, so now we can get a better look at what's in here. Got our pedals, brake pedal, gas pedal. This pedal box is adjustable. Have it all the way forward and could go pretty far back. It fit a big range of drivers, but now that I'll be primarily the main driver, it's stuck up front. I may not, I'll probably keep the pedal box because they can be somewhat complicated, especially since we already have the mounts of how it mounts to. But I could also make something and just weld it in, but this should be fine. The pedals I do want to redo because they are short. I think probably like a little higher than the middle of my foot would hit the pads. So I want to make taller pedals, curved pads, or face, whatever you want to call them, aren't the best, as well as it's pretty narrow. But something bigger that'll fit kind of a bigger footprint on your foot would be better, because this pretty much puts a pressure point wherever you're pushing on your foot, and it's not the most comfortable. We have a couple, I forget if these are Willwood or Tilton. Yep, Tilton. So we had these remote reservoirs, which is just a tube with a bolt in it. I'd like to make something better than that. Get rid of these giant bolts and put like the actual remote reservoirs that are meant to go with these up here somewhere. It's this again, it's got a carbon fiber mount here, similar to the floor that covered the pedal box. Is carbon as well, just a sandwich. It's sturdy enough. Here we can see the front pull rod set up better. The dampers. Had the mounts for sway bars, but never got the sway bars made. And this is just ties the left to right rocker mount, just to try to stiffen them, because it is in single shear. This is how it worked out. You can see where the dampers mount down there, as well as Woodward, the mount for the steering rack. One thing I remember from this is the motion ratio of the rockers wasn't ever, they were calculated, but I guess the springs weren't calculated to go between the motion ratio of the rockers, the weight of the car, and kind of what a ride frequency, roll stiffness, all that was never calculated. These are just taken off of the 2008 car and slapped on here. So the springs here, yeah, it's a full spring. I remember for competition we had a really soft spring, so we cut another spring and had just a bunch of preload to keep it off the bump stop. But now I guess we got, I don't remember when, but put some springs on it. It doesn't do that, but it's fairly stiff. So I'll have to take those springs out at some point, see if they have a spring rate marked on them. Kind of, as well as I want to measure what the actual motion ratio of this is, and calculate the ride rates and whatever, as well as get an ARB actually fabbed up for it. Here's the front upright, machined at a 6061 integrated brake mount. This is solid. This is my first FSAE car that I designed, so that upright was like 2 pounds, which is pretty heavy. And you know, there's a solid piece right there. That being new to it, FEA was kind of new as well. Kind of stuff like that happened, not fully understanding what I was doing. There's the rear upright. This one's a little nicer but still has, some of the webs are pretty thick on it still. Up here, they're not bad. Down there, they're probably thicker than they should have been. So this upright as well came out around 2 pounds. And then there, behind the spherical bearing, is a, kind of see it there. Not really. But he put shims between that, what's actually mounted to the rod end. Shims behind it, between the upright and it, and that shim our camber in and out. And the front had the same. Between that clevis and the upright, you put shims. And that changed the camber. Until, of course, it just changed with the tie rod here, but for the steering. And the caster was not adjustable on this. To do that, probably on these upper mounts, make a wider tab with 3 or 4 or 5, whatever, probably 3 different holes, front to back. You move the upper A-arm front and back, and that'll change the caster, but I'll see if I even need to change caster. It might not matter if I'm just out there to have fun. For the radiator, it ran, I forget the dude who designed it. I think it's a 2-core. But it has, oh, I forgot these are molded as well as carbon fiber to put the fan on, and then the front intake. It's pretty thin, maybe 2 or 3 layers of carbon. But yeah, just had a wet on the mount here, and I think, yeah, it might be too dark. You can see how it was mounted is these 2, I don't know, whatever, stud things. Slip in here, and that constrained the radiator laterally and longitudinally. And these bars here just kept it, I guess, the from pivoting, rotating along the axis there. So pretty good system. Probably could have gotten away with that one and just had the top or one of them, or whatever we had to. We had AN BMRS hoses. These are actually pretty nice. I don't know what this adapter is all about, but there it is. Catch can here. So we had the coolant catch can. I think the rule said it had to be a liter for coolant and oil catch can. So this one, coolant or oil, mounted here. It was sideways. We had the, and whichever way you want, I guess this way. Had the inlet here. Oh, it was this way. Yeah. So inlet here from the motor, from the breather of the motor. And this was just a vent. I think we had a hose on this kind of go down to the ground. And what happened was, from the LTR 450, we had the whole quad when we first got the motor. But we mounted the motor and just went straight from top of the valve cover or wherever the vent was, straight into here, mounted sideways. Thought, and it's just vapor, it'll never fill up, or very little fill up. And then the endurance race for these cars is only 22 kilometers, which takes maybe 20 minutes. So we're like, it'll never fill up. Well, it did. Filled up, got to here, leaked down. The Judges saw oil on our frame, so we got DQ'd right there. Never got the second driver out for endurance. And reason was the Suzuki on the quad had a catch can, but let's say, for instance, it's this, comes in here, would be vertically mounted. Came in, had like steel wool. I'll just hold it. Come in here, steel wool, kind of catches all the oil particles. All the oil would drop down to the bottom, and then this would drain back into the crankcase of the motor, and then you'd have a vent here to atmosphere. But since it vented back to the crankcase, it would never really fill up. The cars after this one, we'd run that stock piece and then run the vent from the stock Suzuki catch can into one of these, the 1 liter as required by rules. But that DQ'd this car from endurance, so that was the fate of that car for its one competition. What we did when we got home, we just mounted it vertical, so it'd actually be able to fill up instead of being sideways. And that was our fix. So we also added that stock Suzuki catch can to it. Gas tank mounted down here, oil tank mounted there, battery. And then, weird thing about this car, you see this roll hoop here goes vertical straight to the ground there. Here, left side, it has a bend right there and then comes in. If you look from this side, you can see how the frame goes straight down. Here, move that firewall, you can see where it bends in. Give that asymmetric kind of a thing to it. The frame is not symmetric. And the reason was the motor was offset. I don't know why. I guess we're worried about scrub of the tires, meaning was shorter. We wanted to keep this section here narrow to have long A-arms. Things move in an arc. The tire, if you just look at it laterally, will move in and out. The longer the A-arms are, the less lateral movement it'll have. It's not necessarily a bad thing with autocross, because if you have shorter A-arms, you're going to get more of that lateral scrub. It could heat up your tires faster, but you also got to keep account that is a lot of energy wasted, as well as you don't want to overheat your tires. But we want to have this narrow, so we offset the motor. I think the car before this one did it too. Offset the motor so we could have this, the diff in the middle and have this part narrow. Bad design, because driver sits right in the middle, motor's to offset. All you have on this side is cooling and gas, which is I think a gallon or so of gas. Not a lot to offset that motor being to the right. So it was right side heavy, which is not ideal. So there's the gas tank mounted in the car this way. You can see it has that angle to match that frame, how I said it was non-symmetric. And then originally when this car we're designing it, it's going to be NA. We weren't planning on doing a turbo. So our engine guy calculated the fuel, the actual shape to be enough fuel, but I guess later with the turbo and whatever, and more calculations, they figured it doesn't have enough fuel, so we added this little handle onto it to give us a little bit more capacity. So it's not that nice looking, it's kind of weird, but that's what that's there for. The side of this car is straight up and down. which isn't the best for upper arms here, putting forces in and out. So straight bars aren't the best in kind of countering that. If you take like a bend kind of here, the tube's not going to be in pure bending. It has a little bit of compression on it. You know, the more you can bend this out, the more compression in the tubes you can get instead of being in pure bending like these are. What I made here is a simple frame, not an entire chassis, but something simple to look at for this idea. For all of the simulations, I set a force of 250 pounds on each side, vectored towards the center. First is the straight-sided frame, made of 1-inch 65 thousandths wall round tube. The material set is steel, and it has a mass of 15.18 pounds. For this frame, the maximum displacement came out to 29 thousandths of an inch. Next is the straight-sided frame, but tubes the force are exerted on are square, but still 1-inch 65 thousandths wall. Mass for this is 16.31 pounds, so about a pound heavier than a round frame, which is 7% heavier in this example. Max displacement is 23 thousandths of an inch. It's only 6 thousandths of an inch difference, which sounds small, but when you look at it as percentage, it's a 26% increase in stiffness. Next is a frame with bent sides, constructed again with 1-inch 65 thousandths wall round tube. Total mass is 15.22 pounds, just the tiniest bit heavier than the straight-sided round tube frame, and it had a maximum displacement of 29 thousandths of an inch, which is also about the same as the straight-sided round tube frame. So I guess the idea my team had about bent tubes being stiffer was never actually tested, and at least this simulation shows the square tubes are stiffer, but I will caveat that I did make a simplified frame, but I believe the results would still translate to a complete frame. So in looking at the two ideas, it's just going to be a compromise between stiffness and weight. What I did to counteract that bending is use square tube. It's a little bit stiffer than round in bending, but I was just doing that to try to keep the frame tight to the cockpit templates to go through here. But the cars that we made after this one, we got rid of that, did a bent tube, round tube. It was a lot lighter and stiffer as well. So it's got some more square. Here's a round. This was square just for the pedal box, and then round everywhere else. So yeah, that added a lot of unnecessary weight. That's kind of the overview of this 2009 FSAE car. My plans for this, number one, just get it running, get it out, driving, just have fun with it. Things I want to change, like taking these catch cans, because they're aluminum with this, whatever, 1/2 inch, maybe 3/4 inch billet mount. A lot heavier than it needs to be, and get some plastic tanks, cut some weight there. On the fuel tank, in a later time, or maybe before I put more fuel in it, cut this off, cap it off, make that flat. It takes up less room, can mount other stuff in the engine bay. Want to take this off, get the fuel pump. It's an in-tank fuel pump. Want to get the pump out and clean the inside of the tank. I don't know what was left in there, if it's dried up, whatever, dirt, and who knows what the state of the sock on the end of the fuel pump. So do all that. See if I have room to get rid of the clutch pedal, and then lighten up this mount here. Figure out springs, sizing, remount, get some actual fluid reservoirs for the brakes. Remake the pedals, make them taller as I talked about. Get rid of the whole radiator. So the inlet actual radiator itself and the outlet here. Rear, figure out springs again, motion ratios. Once I get corner weights of the final car, calculate motion ratio, or calculate spring rate based off motion ratio and the corner weights. Get a smaller battery. I doubt this thing even works anymore, but also it's giant. We can get something more like an ATV sized battery. That's the old mount for the electronic paddle shift. So we can change that up, put it in a different spot. Figure out a better floor. And the steering, it's kind of wonky, this thing here, but it works. Later time I can make it look nicer. Figure out all the wiring for what I need. I think we had switches. Have to have the kill switch, start switch. We had a fan for the radiator, oil pump for the turbo, and a fan for the turbo. We had for the turbo, had its own oil pump, its own oil tank, as well as a heat exchanger that mounted down here. And that heat exchanger, I think it had a fan. I know the intercooler had a fan. But all of that you can clean up, save a little weight. The actual body, do like a experimental aircraft, use a fabric that you basically glue onto the frame, and you use a heat gun or an iron to shrink it and then paint it and then make an actual nose cone. And I'll remake the impact attenuator because this one's full of Bondo and heavy. And that's pretty, the track width is narrow. I forget what this is. I remember it being narrow. And I've seen it get on, a little bit of air under the tires. Wider track width will help that. Make it 60, probably I think 60 inches. I have to go through and look at what the other cars I made were. But that'd mean making new A-arms, longer A-arms to get that track width. And that's probably it for now.